So yeah, as of today, we may not need not use VS Code. We can use
Mm.
something called Google Colab. Okay, so this tool is offered by Google itself. So it
Okay.
gives us like a Jupyter interface, what we were looking at in VS Code, right? Those blocks which we used to code and run, correct?
Mm-hmm. Yeah, yeah.
So this Google Colab has got a same interface. So the specialty with Google Colab is you can write, like, you don't have to install Python separately or create any plugins. Everything is there by Google. So you can just open it in a browser and you can just try to operate over it. You can write your Python code. Okay.
Oh, okay. Okay.
Right. You may ask me like if that's so good, why to mess up like this with this VS Code, right? So
Yeah.
of course. So since we are running LLMs in our local, so Google
Mm-hmm.
Colab is something which is on like Google's server. Okay. So every time for interaction, so as we are running those cells, it has to connect to Google server and run it online. Okay. But this VS Code lets us like run the things offline, and our LLM is running offline, right? So in order to connect to it, we may need something in local ID. That's why
Okay.
VS Code is necessary.
Okay. So I already have it. I've opened it. So,
Sure, sure. Just try to check on like if it has got like Python integration already or Jupyter Notebook if you can open. Okay, maybe later. No worries.
okay.
Hi, Saurabh. Good evening.
Hey Arya. So,
Yep. So was the day?
yeah, it was good. It was good. I just wanted to
Right.
check, Arya. Do we have class tomorrow in Hyderabad? Mostly it's holiday tomorrow.
Yeah, it's already tomorrow, but as of that
We'll have.
means, yeah, we have classes, I guess.
Okay, okay, cool, cool.
It's 5 days
Sure,
per
sure,
week.
sure.
So I'm not
Yes,
sure.
yes, yes. Yes, yes, sure, sure, sure.
Sure,
We'll
I will
start
just
then.
check with the admin team and I will inform you, okay? If that's fine.
Sure, sure, sure. Sure, sure, sure.
Sure. Sure then. Did you get the chance to like you have VS Code already installed?
Yes, yes, I have VS Code.
Okay, sure, sure. All right.
I have VS Code,
So,
Python, and these things are already there.
okay, great.
Yeah.
Sure then. As of we continue with our fundamentals with Python and try to understand like few building blocks of Python.
Okay.
We
Data
can
types
use Google
today.
Colab instead. Sorry.
Okay, okay. No, no. Yesterday you said today we were discussing about the data types of Python and tuple dictionary, all
Yes,
those
yes.
things.
Right, right.
Okay.
So basically, we will discuss them, but again, to try them out instead of like VS Code. Manogna is still integrating like VS Code in a local.
Okay, okay, okay.
So let's
Sure, sure, sure.
try Google Colab, which has got like similar interface, but we can just open it and start playing. Okay.
Okay. What is Google Colab? Is the editor like ID?
It's Google. It's a tool from Google, which offers a Jupyter notebook for free, and
Got it.
it's online actually.
Got it. Got it. Got it. So it's a shared notebook, like everyone can see what you're typing. Is that?
Okay. Yeah. Okay. I'm not sure like how to do that, but I'll just check on it. Okay.
Okay, okay, okay.
As of today, maybe I will share my screen, and later I can
Sure.
share my notebook.
Okay, okay, sure, sure. Thanks, Arya.
So yeah, yesterday, shall we revise like what we did yesterday? So as we do like every day. Mm, so yeah, we revised OWSP like these documents. Okay. So among the 10, we explored like 8 and 2 RAG and agents. We will explore them later, I said. And then we checked on like the difference between these LLMs, AI agents, agentic AI, and fundamentally what's the difference between all those. Okay, I hope you guys remember it.
Yes, yes.
Right. So usually my way of learning is to understand the things fundamentally so that I don't have to buy at them. Okay. So yes, so we started with Python. Uh, okay, let's maybe like start from the basics. That is to understand the Python fundamental data types in Python. and maybe we will just go like in quick rush. Okay, after that. So yesterday we looked into like dictionaries, right? And also list, right? So any doubts on those? Okay, let me just start from the scratch as of Python. We will just rush it out, okay? We don't have to spend like learning Python itself will take a few time, much time. But of course, you guys have got like AI tools for your escape now. So most of the boilerplate code, okay, most of the boilerplate code for all my APIs, I try to create every day, like as a developer, right? So those are actually created by AI. I just fine tune like whatever is necessary depending on like what the API should do and all the security things. That's it, right? So these boilerplate code are usually done by these chatbots, basically. Okay, or we may call LLMs. So you can do so, but we have to understand one thing. So if you don't know Python, okay, you don't know what these LLMs are generating actually. Correct. So you can't rectify the mistakes that's been done by these LLMs, right? So that's why you should understand the basics of it, and then maybe once the LLM generates the code, you can adjust it as accordance with your requirement. Okay. So let's understand about this Python now. So Python fundamental has got like primary data types could be like integer, float, okay, binary, okay, all these, okay. Uh, so example for binary is 0 or 1, 0 or 1, or maybe true or false. Integer is nothing but like 1, 2, 3, 4, what we use, right? Numbers. Those are integers. Float is something like 1.0, 2.0, all these numbers. Okay. And there is something called string. So string is the text that we write. Let's say defending at a scale. This text itself is called like string. String is usually written under this double inverted commas. Between this, we have to write the string, or else maybe single inverted comma. If it is a multi-line string, then we have to use this triple inverted comma. Okay, so we can write up like many lines here in between. All of it is like a single string. Okay, so these are the primary data types. Okay, we may need to know. And as of complex data types, sorry, before that, any doubts here? So what is integer, float, the binary, the string? Manavya or
No,
Saurabh?
no, no, Arya. Please go ahead.
Okay. So these complex data types, we can like majorly four types. That is, the one is list, the second one is tuple, and the third one is like set, and fourth one is dictionary. Okay. So list is also could be considered as dynamic array. So traditionally in Python, we don't have arrays. Okay. So basically, yeah, this is not needed here, but anyway. So array is fixed block of memory. Okay. Let's just say you have to store like a is equal to 1. Here a could be variable. Okay. This one is actually integer, correct? So integer stores 4 unit. Okay. So there is a 4 memory block. So this a actually means this is holding this 4 unit where it is representing 1. Okay. Let's just say 10. 10 is also integer. So these 4 blocks are actually representing like 10. Okay. It may be 100. 100 also presented in these 4 blocks. So integer needs 4 bytes of memory. So these are the 4 bytes. So among which all the integers has to be represented. Okay. So let's just say for an array, traditionally C, C++, Java, all these got arrays. Okay. So array, in order to define an array, we have to make sure we have fixed number of like same data types. That is, if we are storing integer in one block, all the blocks has to store integer. Okay. If we are storing a string in first one block, so we have to store all the blocks like string only. Okay. So the same data type it has to contain, and the size of the array has to be defined as a prerequisite. Okay. Let's just say I'm saying a of 5. So this means there is an array that is called a. Okay. The name of that array is a. and it has got like 5 memory space. Okay, depending on the data type, these 5 spaces are created. Okay, so this is a classical array. Let's say it's a classic example of array. Okay, but we have 2 different types. An improved version, you can say. One is referential array, and other one is dynamic array. Okay, so as of referential array, what this solves is, so arrays has a fixed size and has got like it can only store same data types. Okay, what referential array does is, so it still gets the same size. So we have to define the size earlier, and only we can fit only those number of elements here. But instead of like storing a single type of element, so now here we can store different type of element. So how this works is, so let's just say this is your memory space. Okay. So as of traditional array, it will continuously hold up a memory, and within which we have to store your elements. But what if a referential array does is, so yes, it will similarly hold up this memory, but it will also hold up some more memory, like let's just say some random blocks which are empty. Okay, so it's not sequential anymore. Let's just say the first element you are storing is 1, the second element storing is 2.0. This is integer, this is float type. The third element you are storing is like A. The fourth element could be B. This is string, correct? Different data types. But what it is doing is, so somewhere in the memory, these blocks are created, and these blocks, whatever the location of this block is, right? So it is stored in this continuous block. Okay. So whenever user wants to access this first element in array, he will straightforward access this element, and whatever the value is there, it will present that value. But in referential array, internally what happens is, when you are trying to reference this first element, you are actually referencing the location of the first element. So it will redirect you to the location of the first element, and internally you get B as an output. And when you are trying to access the second element, it has the location of second element. So you can go to that second element location and you get the second element, right? So by doing this, we are solving like one major problem of array, that is we have to store like same type of element. So now we can store different type of element using this technique, and we call it referential array. What is dynamic array? Dynamic array actually solves the problem of size also. Okay, now so you can say like it's a referential area plus variable size. Okay, here the size was limited. Let's say 4 elements. You have to store 4 elements, but you could you could store different types. But what dynamic array does is, so in the same memory space, if the user is first, he wants to like get 4 elements, it allows the 4 elements, and it uses the same technique as referential array. Okay, you can store different data types. But in case the user wants to add fifth element, so earlier in referential array or traditional array, classical array, we can't increase the size directly. Okay, but how this solves is like it will abandon this, so it will copy the whole thing, the whole 4 storage space, and plus another 4. Okay, it will create a new instance where it is holding up like 8 elements now. You want to add the fifth one? Okay, no problem. I will just copy the 4 elements which I already have, and I will allocate like I will double the size of the array. In case now it is 8th element. So you want to add the 9th element. What it does is like it will copy the whole thing. It will create a new memory space of like 16 elements, where it can hold 16 elements. Okay. Now you can add the 9th element. So every time you want to increase the size, the memory space allocated could be like double. It's not in the same memory location, but the next memory location that is available. Okay. So what does this waste space? What it would be done is like this would be like considered garbage value, and it would be cleaned up after a while internally. It all happens in OS. We don't have to care about it. Okay. So these are 3 different types of arrays, and dynamic array is what we call list in our traditional Python. Okay. So this list data type is actually dynamic array internally. All right. So the presentation of this list is, so it is represented in square brackets. Okay. Since there is no restriction of size or data type, we can store n number of like elements here of different data types. Let's say first element could be 1, This is how elements are represented. Second element could be 2, third element could be A, fourth element could be BCD, fifth element could be 2.0 or so, or maybe true or false, all such. Okay. So how many elements? So it could be n elements. There is no restriction with the number of elements that has to be stored in this list. Correct? Okay. So this is the representation of list. So you can assign a variable A is equal to. Okay. You don't have to take A every time. It's your wish. Okay. I can take list 1. But the only restriction with the naming of a variable is it doesn't have to associate with any of the keywords which is defined by like Python. Let's say list. List is a data type defined in Python. Okay. So list has got this name list itself has got some meaning in Python. So you can't name something list directly. You can name it as list 1, list 2, list underscore anything, but not the list. All right. So is that clear? Yes. About list. Okay, great. Yeah. Let's take a quick look at tuple. Okay. So tuple is round brackets actually. So this could be similar. All of the actions or representation could be similar to list the characteristics, but there is an subtle difference between those two. Okay. So yeah, tuple hold n number. It can also hold different types of elements. This can also be 1, 2, A, B, C, D, 2.0, etc. Okay. It can also hold n type n elements. But the difference between tuple and list is, so let me name it tuple 1. Okay. So the difference could be, so once you define 1, 2, A, B, C, D, all this, okay. So you want to add up an element, you can directly add list dot append. There is some method called append. You can pass a variable, sorry, you can pass a value, that is, I want to add like XYZ. Okay. So I'll just pass XYZ as an input parameter. So this list 1 dot append. So now this list is increased to be like, this is the not the limit now. So now it will gain XYZ. Okay. The list is extended. New elements are added. Okay. Two list could be added. Okay. No worries with that. No restriction with that. But as of tuple, you can't, once you define a tuple, you can't add more elements into this. Okay. So what the tuple does is, tuple is more of like an referential array. Okay. It doesn't, initially it doesn't have a fixed size, but once defined, it has got a fixed memory block. All right. So that's why changes in Python, changes in tuple is not possible. That's why when you want, when you know, like, let's just say there is a phone number. All right. So it always, all the Indian phone numbers are like 10 digits, correct? So when you know only 10 digits are contained, okay. So you can use tuple. So let's just say Gmail. So the Gmail accounts could be like different length, right? So you can use list for it, not the tuple. Okay. Something where you know this won't be changing. Let's say ATM pin or Aadhaar number, all those, right? So for those you can use tuple. Okay, because tuple uses very less memory compared to list. But wherever there is a variable, you don't know how much if it needs to be changed later. Okay, that time you can use list. That's the difference between list and tuple. We usually go with the list as it is very flexible to work around. Okay, so whenever you know, so these are the final elements I want. Yeah, you can use tuple for it. So can't we add tuple or can't we delete anything? Yeah. So operations on tuple is possible, but when you operate on tuple, so it will actually create a new memory space. It will not operate on the original memory space which was there. It will create a new separate memory space, and then that operation is performed and a new tuple is stored. Okay. All right. So let's go to, so we dealt with the tuple. Let's go to set. So I understood the tuple and the list difference. How I how I switched on the camera? Oh, okay. Oh, I totally forgot to switch on the camera. Right. Am I visible, guys?
Yes, yes.
Okay, great. Sorry for that. All right. Hope the screen is visible. Uh,
Yes, please continue.
okay, great. So yeah, let's deal with set now. Right. So what is set? Set is represented by like these flower brackets. Okay. So when you want to create an let's just say an empty set, you don't know what to define, but you want to create a set. So that's how you define an empty set. Okay. Or let's just say this is how you represent an empty set. But to define it, you could use it as a set. Okay, nothing. Okay. Set is a keyword which could be used to convert anything to set. If nothing is given, it's an empty set. All right. The unique property of set data type is it only contains unique elements. Okay. So let's say in the list you pass like 100 times the one. One is a single element. You are passing it 100 times. This would list would hold all the 100 ones, and tuple would hold all the 100 ones. No worries with that. But unique element set in since set can hold only unique elements. So although you pass the 1,000 times, it will hold only one. It will only hold once. The one, okay. So any list or any tuple could be converted as set. Okay. As soon as it is converted to set, all the repetitive elements, or let's just say only unique elements are stored in a set. So in a list or tuple, there is something called like first element. One is the first. So let's just say this is the first element. First element could be represented by index 0. Okay. And second element is index 1. So let's just say list 1, right? So if I say list of 0, so I'm actually calling for first element. If I say list of 1 instead of 0, correct? So I'm calling for second element. Okay, this is 0th index, first index, second index, third index, and so on. Okay, so the last nth element would be n minus 1 index. Okay, so list 1, square brackets 1. So to call upon a tuple, the same thing. Okay, so I have tuple 1 is my variable name. Okay, tuple 1 of 0 is first element, tuple 1 of 1 is second element. All right, but as of set, so this set doesn't have any indexes. So there is no first element or there is no last element. It just holds the element randomly. Okay. How you could represent is for list and tuple, it's more of 1, 2, 3, 4, 5. This is first element, second element, third element, fourth element, fifth element. But as of set, it is more of like there is a round bucket maybe, and you are putting up elements there. Okay, they are lying there. They don't have order. It could be 1, 2, 3, 4, 5, 6, 7. Got it? If you want to like get in depth, there is something called frozen set. Okay, frozen set is where you no more add element or you no more can delete element. Okay, this set is completely frozen. That is what frozen set actually means, which we won't be using much. Okay. So as of dictionary, I have already explained you what dictionary is, and to access a dictionary, we will look into it as of today. Right? Are we good with all the data types? Correct. So let's try out those few of them. Okay. So this is Google Colab. You can just write Colab in your Google browser. Okay. Sorry, Chrome, and it will open. So I'll just show you that. Straight. So here, let's say I want to. I'm just writing Colab. Okay. So this is the page. You can go to like Welcome Colab, and here you can check on. You can open a new notebook. Okay. I will not, but I mean, no worries. So once you open a new notebook, Google will load an interface for you. Okay. So this is the interface. So here by default, you can work with Python. So there is something called connect here. You don't have to connect manually. You can maybe type up a, let's say 1, 2, 3. Okay. So this is the list. I will name it as A is equal to, so let's just say I will name it as list1 equals this. Okay, I run this. So it automatically connects and it ran now. Okay. Now I want to print this list1. Okay. Now it is printing, correct? So I can also write like print here. So in Jupyter notebooks, what happens is the last line is actually like actually prints if it can print anything. Okay. So now it is 1, 2, 3. That's what we assigned list1. And as you're printing list1, we are getting the list. Okay. So we can do one more thing. Okay. That's how you can open your notebook. Since I have opened it now, let's operate on the same. So let's check on the type of this. So I'm print. Inside print, I am typing up one of the function, type function, within which, so type is a function offered by like Python by default. Okay. So I want to check what type the list is. Okay. So this is of list class. Everything is object in Python. So list is also an object. Okay. So it is related to class list. Okay. So the list one we defined is actually a list. Okay. Let's just change these brackets to round bracket. Okay. So let's just, so in order to run this, you can go to like this run all here. There is, okay. You can select run here. So here you can see some pause symbol, right? So you can click on it and it will run the cell, or else what you can do is you can click Control Enter in your keyboard. That should run the cell, or you can also choose like Shift Enter. So what it does is it will run the cell, the current cell, and it will go to the next cell. Okay. Those were some key utility handling, you can say. So this is, I'm still naming it to be list1. Okay, naming is your wish. You can name anything. Okay. So now I have used like round brackets, right? So let me check on like for the class of it. Okay, the class is tuple. That means this is a tuple data type, correct? So if I, so the good thing about Jupyter notebooks is, so whatever you have already run, right? So in the new cell, if you are trying to print some variable name of the previous run cell, or use some function which is like previously loaded, right, already run. So you can use it like in a new cell, no worries. Okay. In traditional Python, in the .py files, we have to write the whole code in a Python file and we can run it only once. But these notebooks, these are good for like data science, machine learning, deep learning, and everything, where we can take up like this is kind of like whole file. Okay, I can write more lines here. Let's just say instead of list1. So let's convert this to list, and now I will add up tuple1. Okay, so maybe ABC is my first element. 1, 2, 3 is my second, third, fourth element. Okay, so now I go for set1. So you can see, right? So when I'm using a keyword, the color is changing. So this could not be like this is how Colab is suggesting us that this is the keyword. Okay, this could be specific character from specific characteristics from Colab. Okay, if you are running a, if you are writing a code in a notepad, this won't be visible. Right. So let's just say set1, and here I'm creating. Okay, it is suggesting me, and then I'm creating dictionary. Yeah, it is suggesting me. No worries. So this auto suggestion is on Google Colab, and it works well. Okay. In order to accept the suggestion, you can click on tab in your keyboard. Okay. Any doubts? All right. So just run this. I have run this. Now I will try to print the list. This is list, right? Let me take it to tuple. So tuple1 is our variable name, correct? So if I run tuple1 now, so it is of tuple data type, correct? So these variables, this could be like you can name anything here. Okay. I can name ABCD2 or ABC differently. Okay. Any variable name, that is our wish. So if I type like set1 here, that should present me with a set data type. All right. So let's just say I'm trying to print set1. Correct. And then I'm trying to say dict1. This is the dictionary. So dictionary is key value pairs, right? Dictionaries also are also defined in like flower brackets, but they are of like key value pairs. So A is a key, 1 is a value, B is a key, 2 is a value, C is a key, 3 is a value. So we have certain operations. Let's just say it will suggest us now. Dict1 is my variable name, which where dictionary is different, right? So I can click on dot. So here it actually allows me like it suggests me a few methods which I can use. Okay, list keys. Okay. So as you can see, keys are like A, B, C are my keys. Okay, so that's what A, B, C are keys. Let's just say instead of keys, I'm writing it like values. Okay, 1, 2, 3 are my values. So that is what being printed. So let's just say let's check on like for a key A, we have got a key A, right? So what's the value associated with it? So if I use dict1 is my variable name, in the square brackets, I'm mentioning a key value. Okay, whatever the key I want. So first key. Okay, so this has value 1, correct? So 1 is being represented. Let's change it. Let's say value B. Okay, I've changed the key. Now the value associated with it is 2. So 2 is being printed. Correct? Let's check on like few operations which we can do on a list. Okay, list1 is my variable name for list. Now we have pop operation. Okay, so what pop does is it will remove the last element of my list. That is here it is 3. Correct? So if I write like click on pop, okay, this will actually remove the last element. 3 is the last element. Now if I try to print list1, it has removed the last element now. It should have at least. Right. So we need code, not the text. List1. So now you can see only 1 and 2 is there because 3 is already removed. Correct. So let's check on other operations. What other operations do I have? So I have append operation. Okay. So let's say append 4 is my I want to do. Let's run this. So what append does is it adds up like last element. At the last, it adds up whatever the element is given. So you have to understand one thing. So append actually adds up the element at the last, and the element could be like single element. Okay. I could give a Arya maybe. Okay. It is still a single element. The words need not be like only hey or am. Okay, not continuous. You can write anything in a single line. Okay, that is a single string. Okay, so here you can see this is a single fourth element. Correct.
Can you just repeat Arya once more?
So about the append operation.
Yeah.
Okay. So what append does is append adds single element to the list at the last. Okay, at the last location, it adds like single element that is being passed in this brackets. Okay, you can see now. So I'm writing list1. I'm trying to print it. 1, 2, 4. Hey, I'm Arya. This is a single element, single string, correct? So 1, 2, 3, 4. Earlier I added 4. So 4 is visible here. I removed 3 before that. So 3 is gone already. So then I added 4. And then I added this element called Hey, I'm Arya. So
Okay.
let's just say I want to add something like so it's not a single inverted comma. You can use double inverted comma too for string. Okay. So let's just say like I love India. All right. So just run this. I try to print the list1. So the last element is I love India. Correct. So here there
Yeah.
was a space, and it considered the space too. All right.
Yeah, but why it is showing hey I'm Arya? Because you have already removed it, right?
I didn't remove it. Once it is appended, it's a permanent operation.
Oh, okay.
Once you append it, it is added to the list. It is not temporary operation. It's a permanent operation. Okay.
Oh,
If you
so okay, got it.
So that's why when you added 4, the 4 existed. When you also added like hey Amaria, the hey Amaria added to the next position of the report, correct?
Right, right.
Yeah. So
Understood.
let's just say, so pop actually deletes the last element of the list, while append adds up an element, a value to the last of the list. Okay, last position of the list. Now, what does clear does is, so it clears the all elements from the list. Okay, pretty simple. We don't want to clear it at this point. Correct. So, what does copy does is, this is interesting to be honest. Okay. Let's just say L is equal to, I say list one copy. Then I create like L. I try to print this L. So L has got every element that was there in list one, correct? Okay, so it copies the whole thing. Okay, so maybe once you start exploring Python, you may get this question. Okay, so let's say L is equal to list one. Sorry, L2. Let's write L2 list one. If I do this, and then if I try to print L2, so now this has also copied whole thing from L2, correct? So L2 is equal to list one is copying the whole thing from list one. L is equal to list one dot copy operation, copy function. Okay. So copy could be called as method of this particular class, that is list class. Okay. So let's say operation for this for now, for easy understanding. So I'm copying something. So why to use copy anyway? Correct. That could be the question. So we knew L. So using this pop operation. Okay. Okay. Yeah, you can write them directly. Uh, okay. So L2 pop, what it does is like it removes the last element. So last element of our list is the copied list in the L2 is I love India, correct? So this operation should remove the last element, correct? It removed the last element. Maybe let me print it for you guys. L2. I'm printing it. Now it is 1, 2, 4. Hey, I'm area. The fifth element is gone, right? Correct. Now try to print like list one. Now since we did a pop operation on L2, list one has also like got like operated like on pop. Okay. Now it doesn't have like fifth element. Is it observable, right?
Yes, yes.
Yes. But let's try to print L now. So L still has like I love India, correct? The fifth element.
Mm-hmm.
Why is it so?
Mm-hmm.
Because when we write a variable like L2 is a variable, list one is also a variable. List one is actually our like list, correct? So when we say L2 is equal to list one, we're actually creating like it's more of like I'm Arya. My friends may call me like something, okay?
Mm.
Right. So this is more of like it is referencing the same list. So when an operation happens on either of this name, it is for the same person, right? So similarly, it is the operation is happening on this particular list. Okay. So that's why when I copied it like this, I just referenced it. Okay. There is another variable. I'm referencing it to the earlier variable. So when I did the operation, the actual operation happened on this particular list. So all the names associated with the list would actually get that operation, correct? So that's why the last element was removed from L2 and that operation also reflected in L1 because they are of like for the same person, for the same list, they are of like different names. Understandable? So
Yeah.
what this copy method does is, so it actually creates physical copy and it creates another list and it assigns name L to that particular different list. Okay. That's why when I used copy, the operation I did on list one or L2 doesn't affect L because it is an independent list. All right. Yeah, let me just remove these for now. discontinue. Okay. So let's just go with like what other operations that are important. Count. So this could be useful to deal with data sets, because what it does is, as the name suggests, oh shit, I don't have to this equals here. So this is a list operation. Okay.
Mm-hmm.
Okay. So what it does is, so it actually, if you pass the number element here, it counts
Mm-hmm.
how many times that element is there present in that particular list. Okay.
Okay.
So let's just say I'm including like three times the one. I'm running this now.
Mm-hmm.
So now if I count one, it should be three times. Correct? It is like it searches the number of elements and counts it.
Okay.
Saurabh, I guess you are familiar with this, right? So as you know Python already. Okay. Saurabh is not there in the call?
I think yeah.
All right. So yes, there is something called extend here. So extend, what it does is, so you can add up like let's just say 5, 6, 7, 8. Okay, this is another list, correct? So it is defined in square braces. That's how we define list, and there are elements within it. So can we call it like another list? Okay. So let me run this, and now let me try to print list one. So now it has got like 1, 1, 1, 2, 3, 4, 2, 3. So we defined only 1, 1, 1, 2, 3, correct? But
Oh,
here 5, 5, 6, 7, 8.
okay.
So the list got extended as the name suggests. Okay. So let me show you something else too. So let's just say A is equal to like maybe okay, some words. They are random. Okay. So this is my new list. I run that list. Now if I try to print the A, yeah, that's the list. That's the one. Okay. So now I will say, instead of putting up this new list, let me put up A now. Okay. Extend is also a permanent operation. So now list one contains all these elements. Okay.
Okay.
So now extend A. So now when I do this and when I try to print it, so it has extended more. That
Mm-hmm.
is these words. Okay. Okay. It has a word. All right. Okay. Just ignore it for now. Yeah. So list one dot. So these are the suggested. Okay. So inserting an element, we can pass up like append actually adds an element at the last, right? So let's just run this and check it out. Okay. First, done. So the operation is done. Let's print list one. Okay. Before that, let's just rerun this. This is set, and the operation is done now. So since we rerun this, the original list contained 1, 1, 1, 2, 3, correct? So this has to be the list now. Okay. But we have also inserted 10 now. Correct. So 1 is an index. So I said, right, the first element is 0th index. The second
Mm-hmm.
element is 1 index. The third element is second index, n minus 1. Correct. So I'm here by operating like writing up this method. I'm actually saying for this particular index, that is first is the index, I have to add like 10. This is the element. So now instead of like originally it has 1, 1, 1. So now it has got like 1. The first index, it has inserted 10, and the second index 1, 1, 2, 3. Correct. So this is what insert does. It actually
So,
inserts. And
so all the
yes,
functions that we are performing right now works with only the list or any
yes,
other. Okay.
no. So basically, these operations, these methods run only on the list. Okay.
Okay. Okay.
Yes. Maybe in the object-oriented programming, I will explain how actually these are only run on list. Let's just say, let's experiment. Okay, that's the we'll learn anyway. Okay, let me create a new code block, and here let me say tuple 1. Okay, let me just print this. So we have ABC 1, 2, 3, correct? Let's write up append here, and let's write up HUI. Okay, so now this should throw up an error. Okay, so tuple object has no attribute append. It doesn't know what append is. Okay, so how this is done? How this is like how does this recognize? Is how this is being recognized. Okay, we will understand this when we explore object-oriented programming. Maybe further when we proceed with the Python. I will also start with the module 3, that is object-oriented programming, right? There we will understand how this is enforced in Python. Okay. Okay. So list 1 dot. So what are the other methods? So remove. So if you pass on value, let's just say we added 10, right? So instead of explaining, we can definitely use it anyway. So let's just say 1. Okay, the operation is done. Now if I'll type list 1, so 1 is removed. Okay, let's just say 3 here. So now print this. So it is removed.
Right.
This 3 is removed, correct?
Yes.
So whatever the value you are passing, that value will be removed. So as you can see, earlier I passed 1, but there were 3 ones, correct? So only single element is being removed here. Whatever the first iteration it gets, maybe that is being removed. Okay. Let's just run this. Maybe we will try experimenting. As you can see, there are 3 ones, there is 2, and there is 3, and there is 2 again. Okay. I have run this. So now if I type list 1, so the elements are first is 1, 1, 1, 2, 3, 2, correct? Let's try to remove 2 now. Okay, let's see which 2 is removed. Okay, the operation is done. Let's run this. As you can see, the first 2 is removed. So what it is doing is, it checks with the first element. If it is not the same element as we have passed in to remove, it will ignore it. It goes to the second element, checks if it is the target. No. Third element, if it is the target, no. Fourth element, that's the target. If it is the target, it is removed, or else it goes to the fifth element. So let's just say, let's try to remove 10. We don't have 10, right?
Right.
Let's just check on like what happens. So list dot remove x. X is not in the list. Okay, this is an error. Okay. So yeah, that's what the remove does. We have to pass a value to it, the existing value first. Okay, so clear extend index. So this index, if you pass a value, it will show you the index of it. Okay. So let me just reprint this. So 1, 1, 1, 3, 2 is the element. Let's just say I'm putting up 3 here. I'm running this. So as you can see, 0th index, first index, second index, third index, right? At the third index, we have 3. That is the fourth element. So we are passing a value 3 and it's at the third index. That's why 3 is output here. Correct? Let's just say instead of 3, I'm putting up 4. This should output me like 4. Sorry, 2. Passing the value 2. 2 is at the fourth index, that is fifth position. Now this should return fourth index, correct? So this actually returns the index. So what if we pass it 1? Maybe that's what you were thinking, correct? What if we pass it 1? 1 are like 3, right? At 3 places there are 1s. So what if we pass it 1? So what it is doing is again the same search. From the start of the list, it is trying to check if it's the target. Since 1 is the target, it is just throwing up like that. What's the index of it is? Okay.
Okay. Got it.
So yeah, that's how you understand like how internally it's happening, right? We can read the things. We can read, or I can give a theoretical explanation of all those methods. But that's how we experiment and understand how things are operating internally.
Correct.
Okay, what reverse does is, sorry. So what this reverse does is it completely reverses the list Okay, we don't have to pass any input here. So I'll just put on reverse and try to run the list one. So the last element is the first element, last second element is the first second element, and so on. Correct?
Yeah.
There is one other method which we will explore, and this is an important one. Okay, sort. What it does is, as the name suggests, it sorts the elements 1, 1, 1, 1, 2, 3 in the ascending order by default. Okay. So here, if you for on sort, okay, here opens a dialog box, correct? So this is a doc string of this particular method. So whenever in Python we are writing our custom methods or all these methods, the code is written, right? So we write up a doc string, like what it does. Okay, this is what doc string means. Okay, so it is suggesting what is the sort the list in ascending order and returns none. It returns nothing. That's why nothing is being printed below, correct? The sort. So you can do this for any method. Okay, you can just hover on that particular method and you will get this dialog box where it tries to explain what it does is. Okay, so if you there are two keys. That key is none here. Okay, so what does key does is uh, if a key function is given, apply it once to each list item and sort them, ascending or descending according to their function values. So let's just say you want to arrange something in an order. You want to give a formula kind of thing. Okay, so you can give it, and according to that, in an ascending or descending order, it will sort out. That's what key is for. As of simple terms, the other element, the other parameter is reverse. So sort ideally uses like what it does is it arranges the things in like ascending order, correct? So if I put reverse true, I don't want to print this. I have already printed. Okay, reverse true and run this. So what it does is it arranges the things in decreasing order. That's simple and straightforward enough. Okay, those are the operations with the list. Let's proceed with tuple. So yeah, there are some other operations which I want to define. Let's say instead of list one here, let's call it L1 for straightforward. Okay, simplicity L1. So now if I try to run this list one dot sort, list is not defined, correct? So I changed the name as L1. So list should be not defined now. So this is working because earlier we have run the list. Okay. Now in as of the collab is concerned, there is some variable called list one. Although we changed it here, it doesn't understand. Like once we have run list one exists for it. Okay. So unless we assign something like exclusively here, it doesn't. List one is let's forget this list one for now. So we have defined L1 again. There is a new variable L1 which is referring to this particular list. Okay, let's try to print L1 now. Right. So let's try to create one more list, maybe ABC, maybe XYZ. Okay, this is another list. I'll just run this. Now this should have created L2, the second list. Great, right. Like there are two lists now. So let's write list one plus L2, L1 plus L2, correct? So what it does is it adds up both the list. Okay. If you run L2 plus L1, so this is temporary operation. Okay. If I assign this operation to something L2 or L1 equals. So if I do this, then whatever the operation is happening, right, that becomes the permanent operation for L2. Okay. If not, this is a temporary operation. So let's say L2 plus L1. So what it does is first L2 elements are added, then L1 elements are added. Correct. So now if I exclusively print L2, L2 is still the same and L1 should still be the same. Correct. So let's assign L1 here. So let's say let's assign L2. L2 is equal to L2 plus L1. Let's run this. Nothing should be printed below because this operation returns nothing. because whatever the operation this was returning, right, that was being printed. Now this is assigned to L2. So whatever is being returned actually passes to L2. Now if I try to print L2, the L2 has changed, correct? That's how you convert this temporary operation to permanent operation by reassigning it to like L2. Okay, so you don't have to do this. We can take up L3. So L3 we have not defined. We have L2 and L1. So let's check if L3 is defined. No, it should throw up an error that it doesn't know what L3 means. Correct? It is not defined. So now L3 is equal to L2 plus L1. This should define L3. Now L3 should be the list which contains L1 and L2. Okay.
Oh no, what is the difference that we have done?
Okay. So L2 plus L1. L1 is a list. L2 is a list. Correct. So
Yes.
this operation is adding up both the list.
Okay.
So first L2 is whatever the elements they are considered, and then L1 elements are extended. It's more of like extend method we used.
Correct.
Okay. So this is a temporary operation. When you are adding something or you are using like minus subtract symbols, these are temporary operations. Unless you assign this operation to some variable, these are never stored. Okay.
Correct.
Once you store them into some variable, maybe L2 or L1, L3, because they are all variables, right? Anyway. So if you once store them using this assign operator, that is equal to operator. Okay. Now these things, whatever the temporary operation was there, right? So this becomes permanent operation to this particular variable. That's why now L3 is defined, and this is what L2 plus L1 is nothing but L3. Understood?
Yeah. Okay.
Make sense?
Yeah.
Okay. So let's say this is L3, whatever is presented here, correct? So maybe we can say L3 is kind of like this is L1. Sorry, this is L2. Initially what we thought of. Then this is L1. And again, this is L1. So we did a lot of operations, right? Somewhere we did a permanent operation where that we named it L2 is equal to L2 plus N1, correct? At that time, this becomes a separate list. That is these elements. So this is L2 plus L1. We named it L2. So now after that we added L2 plus L1. So this list was again added to L1. So this is L1 elements, correct?
Yes.
That's why L3 contains these elements. Now if I try to print, okay, let me just put it L3. Let's check on visible difference here. L2. Okay. And this is L1. Okay. So let's do some operations here now. So let's just remove this L2 minus L1. Okay. So L2 has got all the elements in L1 and extra elements, correct? So now I will do the operation L2 minus L1. Right, unsupported operands. Stateless. Okay, this shouldn't have been the case. L2 dot L2 minus L1 should have worked. Okay, I will check on this. Maybe for these errors, the easy way is to like click on the explainer and Google Gemini. Uh, so I guess Gemini 2 is making work or Gemini 1.5 is in work here. So it explains you what's the error is and it gives you an explanation. Okay. Anyway, All right. So we can't use L2 minus L1. All right. So let's just say L1 multiplied by like twice, 2 times. So every element, okay. So this L1 multiplied by 2, what it is doing is, so L1 is 1, 1, 1, 2, 3, correct? 2, 3, 2. This is L1, correct? So now we are multiplying it by 2. Like it is creating two lists. Okay, let's say this is 3. So it essentially creates 3 lists. All right. The same copies of the same original list. So usually whenever we are printing so many things in a single file, right? How it does is like to make sure the visible difference happens. So this is a string, correct? I have written star. There are no words, just the symbols. So this is also a string. So this is inverted commas. It is in inverted commas. So it is a string. So we'll just multiply this like 15 times maybe. By print this pattern is generated maybe 50 times. So if we want a visible difference between like two statements, we do all such. Okay, maybe remove this hash and type up like instead of stars, let's use hash. Okay, these things this is for utility. Okay, no worries. Yeah, so that's our list operations. Let's check on tuple operations. Before that, let's just remove these. Can I remove these?
Yes.
I'm just asking because so that we can refer these easily.
Mm-hmm.
So I'll just remove these and here tuple one, my tuple operate tuple. So just dot. So we can't append delete things directly in the tuple. Okay.
Mm-hmm.
If we do, it will create a new tuple. This
Mm-hmm.
is count. It is similar to like what actually the list has, correct? So it counts the number of same values within that
Okay.
particular tuple. And this is index. Yeah, we have checked with index, right? So the same what it is. So for an element given, so it checks what's the index of that particular element.
Mm-hmm.
Like ABC, this should be first element, that is 0th index, 0, correct?
Mm-hmm.
So these are they seem to be like simple operations. So when we
Mm-hmm.
do this at scale, they become essential. The properties of those becomes
Oh.
essential. All right.
Mm-hmm.
Yes. So let's create one more tuple. T2 maybe. T2 is equal to 1 comma 2 comma 3. Then let's try to add these two tuples. Tuple 1 plus T2. Correct. Both are two tuples. Correct. Let's try to add these. This will create another tuple, but the location of these tuples could be different. Okay.
Mm-hmm. Mm-hmm.
So the location of tuple 1 is different, tuple 2 is different, and this operation created one more tuple that could be like totally different. All right. We'll just move on to set. Yeah. So I have set 1. Set 1 has got like few elements 1, 2, 3. What are the operations available? Add, clear, copy, difference update, discard, interact. So are you familiar with set operations in mathematics?
Yeah, yeah, yeah.
So all these operations are nothing but set operations. Okay.
Oh, okay.
Yes. So let's just say add. So what it does is let's just say 4. Just over this. So we'll take okay. This adds. This is so usually for permanent operations you won't get like it returns nothing. Okay. For temporary operations, this isn't like a direction you can understand. Okay. There's a thumbs up, a thumbs rule. if some operations happens, if it doesn't return anything, although it is in the last line of Jupyter notebook, it is a permanent operation. So this add, we can say this is a permanent operation. Something has to be written there.
Okay.
So now let's try to print set one. So this should contain 1, 2, 3, 4, correct? So we have added that. That's why. Not clear actually clears out like everything within that set. So copy actually copies it. We have seen it already in list, right? So difference, yeah, this could be interesting. Yeah, but before using difference, let's create one more S2 maybe. Okay, so what it contains is 1 comma ABC comma XYZ. That's it. Okay. So if you don't start the string by inverted comma or a double inverted comma and end it as the string ends, this could throw up an error. Okay.
Yeah.
All these things they throw up like error, and we have to understand the error and write it. Okay, this is S2. So there is set one and there is set two. We have printed set one. Let's just also print S2 for reference. Okay. So now in the set difference, I'm passing one more set, that is S2. So the difference, what the difference does is like it is trying to like whatever the element that is in set one, which is also in set two, it is trying to discard those. So set one had like 1, 2, 3, 4, correct? Set two had like 1 A, B, C, X, Y, Z, correct? So now one is removed as one is common, correct? Let's interchange this. So say I'm putting set one here and set two there. It's two, correct? So now what it does is it shows A, B, C, X, Y, Z because one has been removed, correct? So that's what like difference operation does. Understandable?
Yeah.
No worries then. Okay. So I want to write this. Let's just check what it does. Built-in method difference update. Okay. So what it does is, so whatever the difference element is there, right? Maybe this was a this is what it does is like it's a permanent operation maybe. So let's just try to run. Okay, this is a permanent operation. So earlier it was a temporary operation. It was just showing us a difference. So now what it does is it updates the set S2 with the return with the difference. Okay, if I run S2 now, it shouldn't have 1, right? It updated the S2. Okay, so difference and difference update. The name suggests it. Yes. So discard, it discards an element. Okay. So intersection. Okay. So this will find out the exact similar elements within two lists, as the name suggests. Intersection updates. So it will update. Uh, okay. This looks interesting. Okay, let's just try it out. Name S1 is okay. Yes, ours is set one, right? Okay, set one. Now try to print S2. S2 is an empty set. Okay, so it updates the S2 with the common elements. Okay, so the S2, let's rerun S2. S2 has one now, one ABC XYZ. Now S set one has 1, 2, 3, 4. So originally S2 should be like 1 ABC XYZ. Now once we run this, S2 should only contain 1 because that's the only common element, correct? Yes, it contains 1, correct? So that's what intersection update does. Uh, so is it 10 10 already? Oh,
Yeah.
okay, it's been almost 1 hour plus. Oh shit. I didn't got with the times. So it's check is disjoint actually checks with like if this particular set is disjoint set. Uh, if it this checks if this particular S2, if I write S2 dot is subset of set one, it actually sets if S2 is in subset of S1. Okay, is superset. So that checks if S2 is a superset of like whatever the set that I'm providing. Okay. But the pop operation here could be like much interesting. Okay. Let's run this S2 first. Okay. Now let's do pop. So here, as you see, the first element is being removed, correct? So in list and tuple, the last element was being removed. Okay. So let's add a few elements here. So adding up all these elements should doesn't affect much because more, it is 3 times 1 again. Okay. So as S2 converts all these like contains only unique values. Now if I print S2, they should contain 1, 2, 3, ABC, etc. Correct? Now let's pop this S2 dot pop. So the 1 is removed. Okay. Now 2 is removed, 3 is removed, XYZ is removed. Okay. So it is not going in order as you can see. So I had 1, 2, 3, ABC, XYZ, correct? So initially it removed 1, next it removed 2, next it removed 3, next it removed XYZ. Right? So why not ABC? ABC doesn't have any superpower, right? It's a simple string. So why this is happening? Let's try it again. 1 is removed, 2 is removed, 3 is removed, then XYZ is removed. Now if I do again, ABC is removed. So what it is doing is, so how set works internally is, so set whenever you are provided with a set of numbers or set of elements, okay? So it internally creates an hash table. Does it arrange the things? It contains like with some logic, it arranges the things within itself. Okay, it is not indexed. So if you pass first element, so let's just try it. So if it arranges things, S2 of 0 should provide me with first element S1, right? Set object is not subscriptable. So there is no index here. Okay. But then why the pattern is similar? Because since it is using some formula to arrange the things, from that formula, there is a new index that's being created. Okay. And this pop operation, what it does is, according to the increasing order of that particular, how the order is, it is removing the things. From the internal logic, it has got, we don't know what the logic is. XYZ comes before ABC. That's why XYZ is removed before ABC. Okay. Yes. That's about the set. We'll just have a quick discussion in dictionary. Tick 1. So we explored few elements, right? Tick 1 dot dot. So these are the things. So from get, you can get like you can pass the key. That is, if you pass A, one is fetched. If you pass B, 2 is fetched. C, 3 is fetched. So it is similar to doing this operation. Okay, this also fetches the value. Dot get. Maybe we must pass a key. So this should also fetch the value associated with it. Okay. Then comes clear copy. You know copy how it works. Yes. From keys. Okay, I haven't explored on this. Let me check on what it does. So create a new dictionary with keys from an iterable and a value set to value. Okay. Okay. So iterable means it could be list, it could be tuple, where we can go on. Like this is first element, right? First element, second element, third element, fourth element. We have to have an order. Okay. All those could be said to be iterables. Okay, we will explore more on iterables later. For now, list is an iterable. You can understand. So this is the
Okay.
list, correct?
Mm-hmm.
So it is asking me to pass the list. Let's pass it and check on like what happens. So 1 is none, 2 is none, 3 is none. Okay. So whatever iterable or whatever elements you are passing here, that becomes the key for this particular dict1. Or maybe let me check on this. A. So this is purely experiment. I am not sure on like how this works, but I'm assuming I understand how it works. Okay. So A, B, C are my original dictionary dict1. Okay, from keys C. Actually, but none is being printed. Let me just try to print dict1 again. Dict1 is still originally ABC. That is, if I pass it to dict, try to run D. Okay, so what it is doing is, so whatever the iterable you are passing, all the values within that iterable. For instance, this is list and all the values within the list, it is creating a new dictionary. Okay, with these keys. Okay, it doesn't associate any value. Now I can associate any value like D of A. I can write equals maybe XYZ or ABC for simplicity. Okay, if I run this and then if I try to print D, now instead of none, it should show ABC, correct? It is taking iterable and all the elements are converted to like keys. Okay, and we may assign values. So when this could be useful is, let's just say you have a table and you have like a student table which has got marks, names, register number, or all his internals assessment, total Aadhaar card number, all the details, correct? So you can pass all those details as this particular list, and you will get a dictionary where no value is associated, only the keys. Okay, there is some key called register number where you can put your register number. There is something called IA1 where you can put it's an internal assessment one marks. Okay, for that this could be useful. Okay, dict1. So have you got like any tasks now? If that's so, we can in the class. It's already 10. We're over. Okay.
Yes.
So have you got like time to continue or?
Yeah, I'm okay. But for
Oh,
you, yeah.
all right. Sure. So I'm just checking like if you had some other work arranged after this class,
Mm.
maybe I'm not sure. Right.
Okay, okay.
Yes. So yeah, pop. What it does is it actually pops a random element from the dictionary. Okay. So what uh, putting up these items, what it does is it prints all the elements actually. Okay. So in a tuple, this is a tuple list of tuples where the first element is key, the second element is value, key value pairs. Correct. Okay. What get does is like what get does. So keys actually prints only the keys. Items print like all the elements from key value pairs. There should be something called values. Yes, this prints only the values. Okay, set default. So what it does is, so earlier it created we created dictionary where none was being printed, right? So value was none, correct? So if we create this parameter, if there is nothing as an key, by default, if you are creating only the value, or whatever the default value you provide, right? That will be the value for any key that you create. Okay, you can change it later, but by default, that becomes the value for your new key. So update actually updates the things. Okay, it is suggesting already. D4. Okay, we don't have D, but if we run this, we will get D, right? So yeah, that's pretty much about this. So pop randomly pops an element, pop item actually pops particular element that you provide. Okay. Of at least expects one argument for 0. Okay. Okay. It popped one first element. Now first element is not visible, correct? So yeah, in dictionary there is no first element or second element. It's more of like key value pairs. It is of list. It's a bucket of like kind of two pairs. That's it. Okay. So once you pass a key, so it removes the element from the dictionary, and that's why you can't see like a associated with one value. Okay. That's on the dictionary. Those are the fundamental data types of Python. I think we spent more than what needed for this particular data type sessions. Okay. Sure then. Any doubts until now?
No doubts. I think I have to start
Very
practicing all
much
these
this.
data types.
Right.
Yeah,
Yeah, no biggies. So this takes time. Okay. So
yeah.
if you could understand at least 30 to
I
40% of it.
understood. Yeah. I understood the functions, but the thing is, the more that we practice, the more I could
Yeah,
apply
true.
easily.
True. Definitely. Yes. So that's it. Yeah, we may need to sprint more faster than this. So I guess I spent more time into data types.
Mm.
Okay. I guess I hope it wasn't boring for you. So I may
No.
start explaining, no issues with me, but yeah,
Mm.
sure then. Any
Thank
doubts?
you.
No doubts, right?
No doubts. No doubts.
You understood the operations pretty well.
Yeah.
Okay. Maybe if Saurabh was there, he would have like got bored because
Mm.
these were like basic fundamental operations.
Mm.
All right. Anyway, try to experiment with it. Try to create some errors and try to understand what the error is, and
Mm.
then you would understand the actual Python. Okay.
Mm. Sure.
Sure then.
Thank you. Thank you,
Have a good
Harish.
day. See ya.
Have a good night. Bye bye.
Yep. See ya.